All right, students, let's go ahead and get started with the study guide for Unit 4. So when I show you these 4 pictures right here, right, are you able to label them as positive slope, negative slope, zero slope, or undefined slope? So if I put letters on these, right, so that way we can easily communicate, which one would you consider to be positive slope? Exactly, it would be C. Okay. Which one would you classify as negative slope? Okay, thank you. Which one would you classify as zero slope? D as in David. The flat horizontal lines have a zero slope. And then this one would be undefined. All right, in ways of calculating the slope formula will be given to you. You do have to know how to find it. So that would be y2 minus y1 over x2 minus x1, okay? So it's just a matter of you knowing which are the 2 points. All right, so for example, if I give you a graph and I say find the slope, there's multiple ways that you can do this. You can also just count the boxes, right? Because you can clearly see this is a negative slope, which means we're going to be looking at a drop and a run, correct? So pick 2 points. So we're going to go ahead and pick this one and this one. This will be your starting point because it's the leftmost point. And the drop here is 1 unit, right? So the drop is -1, and the run is 2 units. So the slope here is -1/2. Now, if I give you 2 points, all right, for this one, you do have to use the formula that we wrote at the top. What I would do is I would stack the points to make it a little bit easier. So we got to subtract the y's. So I'm going to start with the 1, and I'm going to subtract 2. 1, subtract 2. Then I'm going to start with the 3, and I'm going to subtract that -2. So it's 3 subtract -2. All right, so using your decimals or your calculator, when you do this, you'll get, what is this, -1 over 5, so it's just -1/5. So if you don't get this in the calculator, you're probably not typing it in correctly. Make sure that you ask for help on that. Now, if I give you a table, do you know how to find the slope? So you got to pick 2 points. If they don't tell you which points to pick, then you can pick the first point and the last point. I would stack the points, 0, -1, 3, 2. And once again, I start with the bottom one. I start with the second and I subtract the first. With that mindset, that's how we were able to do our sequences, okay? So 2 subtract -1, and then 3 subtract 0. Yeah, so that's 3 over 3, so that equals +1. So what all these different types is telling you is to be ready to calculate the slope depending on the situation. Now, when you look at this function right here, if you look at this function right here, do you know which one is the slope?
Yes.
3 over 2, not the x, just the 3 over 2, okay? So the slope is 3 over 2. You have to be able to recognize that this is in y equals mx plus b form, with the 5 being the y-intercept. All right, so there are more than 3 equations. There's just several equations that you need to know to be successful in this unit. Slope-intercept form of a line, which is y equals mx plus b. with M being the slope, B being your y-intercept. Standard form, which is good for solving systems. A, capital A, lowercase x, plus capital B, lowercase y, equals 0. Oops, sorry, my bad. Equals C, a constant. This is general. Basically, put all the terms with your variables on the left and all the constants on the right. Point slope form, less popular, but nonetheless it exists. Y, subtract the y1 value, the slope, and then x, subtract the x1 value. Now, I also hope you didn't forget about this part right here. Horizontal lines. This is the acronym to help you remember horizontal lines, HOY. Horizontal lines have 0 slope, they start with a Y. So if you see Y equals a number, that means it's horizontal. So an example would be Y equals 3. It's a horizontal line that goes through Y equals 3, and it has a slope of 0. Horizontal lines are basically like walking straight on the ground with no slope. VUX is what you're supposed to remember for vertical. Vertical lines have an undefined slope and they start with X. Okay. So if you see X equals a number, like X equals 7, that's a vertical line at X equals 7. This one would be a horizontal line. Horizontal lines and vertical lines have a very specific form of their equation, right, that you should be able to tell miles apart. So does everybody know how to do rise over run? All right, so with this one right here, we have 2 specific points. This point right here and this point right here. So we're going to start with the point on the left, and we're going to go towards the point on the right. It's a positive slope, so we'll do rise and then run. So starting from this point, you go 1, 2, 3, 4, 5. So you go up 5, and then the run would be 1, 2, 3, 4, 5, 6. All right. So in writing the slope, how do we write it? 5 over 6 or 6 over 5?
We don't have the
All right, this other one, this one is a negative slope. So it is this point and that point. This is the leftmost point. This is the rightmost point. So even though you don't have lines on this, you're actually counting the numbers. So it makes it a little bit easier. So dropping from the 2, I'm dropping once, twice, 3 times, 4, 5, and 6. And the run happens to just be 1. So the slope here would be negative 6 over 1, or just negative 6. Okay. Because while Desmos can give you the graph, it's not necessarily going to tell you, oh, this slope is negative 6. Okay, you do have to know how to do some things on your own. All right, for quick graphing. All right, so how do you identify the line for this one? Well, there's key things. First of all, the y-intercept. This line should be going through this point right here. And then the slope is 1 over 3, which is rise 1, run 3. So rise 1, 1, 2, 3. Okay, rise 1, run 3, 1, 2, 3. Okay. Anyway, so you can just you could probably cancel out a lot of choices if you have those basic requirements for that line, okay? All right, the next one. Which one is the y-intercept here? The slope happens to be negative. So this means drop 1, run 3. We always run to the right. This is how you know that you've practiced graphing lines the way we learned it in this classroom. Drop 1, run 2, 1, 2. And you can do it again. Drop 1, run 2, okay? So being able to know your basic key features of your lines is very important. All right, here's something else that Desmos won't do for you, okay? Aiden, McMichael. Stop carrying on a conversation while we're doing the lesson, okay? Now, when you're trying to solve this, you're solving for y. This is like literal equations that a lot of you guys say, oh, I have such a hard time with. No, you don't. You know how to do this. This term is the one that has the y. And it's already on the left. So we have to get rid of minus 2x. Plus 2x on both sides. Correct. All right, so we do this because this is a 0 pair. We're going to carry the 12y. Okay, Kate and I don't need the musical. Now, what is this? Does this become 110? Does this become 110? They don't, right? Because they're not like terms. So we write the 2x first and then the plus 108. Is there a reason for that? Yes, because we like to keep the form of y equals mx plus b. Okay, that's why we write the term with the x first. All right. Now here's the trick. When dividing by 12, you need to remember to divide every single term by 12. This one, as well as the 108. Right? So. All right, don't tell me the answer is 6, because that don't tell me that. The answer is not 6. What's the answer? Correct, 1/6. And what's 108 divided by 12? Okay. Are we there? All right, so now, all right, this one right here is the one that has the y. So the one that we need to move is the 4x. Since it's positive, we need to subtract it. Okay. Beautiful. See, now all we have is 4y on the left. And what does this become? 28? Exactly, they're not the same, right? Yes, I was trying to trick you guys. All right, and we're going to write the minus 4x first. We're trying to maintain the y equals mx plus b format. And then you also have to divide every term by 4. All right. Negative x plus 8. Don't lose the x. All right. What I did here is kind of like a little matching game. These 3 choices right here belong to one of the graphs. Okay, so one of these graphs is one solution, one is infinite solution, and one is no solution. Then, I'm going to give you time to do all 4 of them. These 3 right here, once again, belong to one of the graphs. So what this is doing is, do you know your characteristics? Do you know what type of solutions they have? Do you know what type of lines they have? What type of y-intercepts and what type of slope? So each of these will have 4 answers. So go ahead and take a moment and distribute them, decide how you're gonna do this. And then we'll continue in just a moment, okay? All right, so the first one, what type of solutions is A?
No solution.
Yes, this one is no solution. What type of lines are these?
Parallel lines.
Yes, they're parallel lines. And what type of intercepts do they have? The same or different?
Different.
They're different. Look right here. This one crosses here, and this one crosses here. In fact, they even tell you y-intercept is 3, y-intercept is 1. They're different. Are we clear? They can't be the same because they're parallel lines. And what about the slope? They cannot be different slopes because they're parallel lines. So they have to be the same slope. That's what makes lines not touch one another, because they have the same slope. Okay? So they'll never overlap. Okay, Jelon, your phone? It's telling you how many solutions does this middle graph have. Oh, it's not? Okay, well then put it away or throw it away because it's no good then, okay? All right, the solution here is how many? One solution. That's this point right here, 2, 1. What about the lines? They're intersecting. All right. What about the y-intercepts of these lines? Are they going to be the same or different? Okay, for those of you saying the same, watch. Where does the blue line cross? Where does the red line cross? And do they cross at the same place? Thank you, Kaden, for changing your answer at the last minute. Yes, they're different y-intercepts. What about their slope? What about the slopes of these 2 lines?
They are the same since they intersect one.
Why? They're different.
All right, so I'll try to explain it like this. Okay, to be parallel means that your rise and your run is the same. That's why you don't end up touching. Your rise and your run ends up being the same. That's why you have the same slope. So parallel lines will have the same slope. The only time that that's going to be also the same is right here with this scenario over here with scenario C. They also have the same slope. They're not parallel lines, they're overlapping lines. But it's literally almost the same thing. I mean, it's like they're the same line. Their rise and run is the same. Here? Whereas each of these 2 lines have different slopes. They're rising differently. One is steeper and one is not as steep as the other one. That's what causes the intersection. So then, intersecting lines are required to have different slopes. Lines with the same slope would never meet unless they overlap. All right, the solution here would be infinite. And the y-intercept here will also be the same. Why? Because both lines are crossing the y-intercept, the y-axis at the same place. Okay. So please make sure that you re-familiarize yourself with the properties of lines, okay? All right, so, okay, we've talked about this. Now, if you can please open up your Desmos and graph these 4 lines very quickly and determine the solutions. Okay, here we go. All right, so when you ended up graphing these 2 lines, where did they end up meeting?
-1, -2.
So -1, -2 is the solution. Right, I guess somewhere around here, and not the perfect slope, but I just kind of want to get you an idea on when you graphed it, it ended up looking something like that. That's how you know then you have one solution. When you graphed the second set of equations, what was the solution? Why no solution, hon? Because they were parallel. So there's no solution because when you graphed it, you ended up having two lines kind of looking like this, okay? And you can double check the slope, by counting your boxes, rise and run, but they're parallel. They'll never intersect, no solution, right? All right, when you ended up graphing the third one, what did it look like? What was the solution? Is it? Wait, why are you saying 4, -4 if it's infinite solutions? Infinite solution means that there's an infinite number of x's and y's. All right, so it's just infinite solutions. Okay. Now, is this end up being a positive slope or a negative slope? Negative? I don't know, so fourth period. I don't know where it intersects because y'all didn't tell me. I'm just drawing a line. Okay, so what's the question? You have to graph it. That's why I gave you time to graph them so that you can see them. If you copy what I have on the board, it may not look like the way it's supposed to be graphed. I didn't graph them. You were supposed to graph them. But nonetheless, it'll be overlapped. You're only going to be able to see one graph at a time, okay? All right, the next one. For those of you that took a moment from the time that I gave you to graph them, what did it end up looking like? -1, what? -1, 2. So you had one solution. Yes or no? So over here, so I don't know which way the lines went. I think one of them went like this or something like that. All right, so this is what it would look like when you have one solution. And I want you to be able to graph and feel comfortable with the results that you're seeing, being able to interpret them. It's what I told you. Desmos will graph it for you, but Desmos won't tell you anything else. You still have to have the knowledge to get it. All right, we're going to continue. So now I'm going to give you some time to get both of these systems graphed. All right, so when graphing this system, we just have to make sure that we graph it correctly, and you can use Desmos for this. And the slope is 1, so it's going to be rise 1, run 1. Okay. All right, so this line right here, if you look, it has an equal sign, so it's going to be a straight, solid line. And it says that y has to be greater than or equal to, so that means that the shading happens up here. All right, let me change the color on this. This one has a y-intercept of -1, and the slope is -1, so drop 1, run 1. All right, this one also has an equal sign, so it is going to be a solid line. And it says greater than, so the shading is going to happen this way. Now, the question is 1, -2 a solution to this system? The first thing is you need to understand where is 1, -2, and it's right here. It's on top of two solid lines, so then I would say that yes, this is a solution to the system. So as long as you fall on both lines at the same time, both solid lines at the same time, then yes, you would be a solution. All right, so now graphing this one, y is greater than -2. So that's a solid, I'm sorry, that's a dashed line that's horizontal, is what I meant to say, at -2. It says greater than this, so the shading is going to happen here. It's going to be all the points above, but no points on the line, because the line is dashed. All right, let me change the color so I can graph the other one. This one says y is greater than or equal to negative 5x plus 3. So it crosses at 3. The slope is down 5, run 1. So 1, 2, 3, 4, 5, run 1 right here. And this one has an equal sign, so it's going to be solid. Okay. And it says greater than, so it's going to be on this side of the line. All right, so this is slightly different because you see this point right here, one of the lines is solid and the other one is dashed. So because of that, that point would not be a solution. Let me get a different color pen. And it says, is negative 1, 3 a solution? Then I would have to say no, because negative 1, 3 falls in the region where you have solutions for only the green line. Okay, so it's not a solution to the system. That means to both lines. Only the points that lie here are going to be solutions. The points that lie here. Okie dokie? Sound good? Sounds good. All right, so now we're going to write the recursive formula for the following sequences. Let me get my calculator. It says 15, 8, 1, negative 6. Now, it doesn't tell us if it's arithmetic or geometric, so we're going to have to check. So then in my calculator, I would do a quick check. 8 minus 15 is negative 7. 1 minus 8 is negative 7. Negative 6 minus 1 is negative 7. So it looks like it is arithmetic, and the common difference is negative 7. Recursive formula. To write the recursive formula, you start with the first term, and then it's a sub n minus 1 plus the common difference, which is negative 7. Let's look at number 3. Write the recursive formula for a sub n, the nth term of this sequence. But once again, they don't tell you if it's arithmetic or geometric, so you need to check. 21 minus 7 is 14. 63 minus 21 is 42, so it's not arithmetic. All right, so we're going to check to see if it's geometric. 21 over 7 really doesn't look like it's going to. All right, so this one is 3. 63 over 21. It's also 3. All right, so then this one is going to be geometric, and the common ratio is going to be 3. All right, to write the sequence is a sub 1, 7, and then a sub n minus 1 times the common ratio, which is 3. And that's it. All right, so this one says to write the explicit formula for the following sequences. And they don't tell us what it is, so we need to figure it out. So we're going to check negative 9 minus 1, which is negative 10. Negative 19 minus a negative 9 is also negative 10. All right, so this tells us that it is arithmetic, and the common difference is negative 10. And this formula goes a sub 1, which is 1, plus common difference times n minus 1. Okay. All right, write an explicit formula for this sequence. Let's determine if it's arithmetic. It kind of looks geometric, but we'll see how it goes. It looks geometric because if I do 28 divided by 2, the 28 divided by 14, I get 2. And 14 divided by 7, I also get 2. So it is geometric. Common ratio is 2. And this explicit formula goes like this. The first term, the common ratio raised to the n minus 1. Okay? So I hope this is helpful in reviewing Unit 4.